Hello, my name is Sean Betts. This is my week 6 assignment for SDI FTT 122, Introduction to Ammunition and Basic Ballistics. I'll be citing SDI Introduction to Ammunition and Basic Ballistics workbook, course text, chapter 9, recoil and cycling, transitional and exterior ballistics. This week's assignment, I was asked to discuss trajectory and sights, gyroscopic drift, drag, Magnus effect, Coriolis and Eötvös effects, vertical angles, and transonic ballistic performance. Transonic ballistic problems. The transonic problem occurs with supersonic projectiles that drag has slowed down to subsonic velocities. The transonic region ranges from about 788 feet per second up to 1340 feet per second. You have a projectile that's going at a supersonic speed, and then it incurs drag. The drag slows the velocity down. It slows it down to, now it's at subsonic speed. So when it incurs that drag, it can create an imbalance in a projectile. So instead of the projectile going straight, it starts to wobble because the drag has slowed it down. And that's your transonic ballistics. Vertical angles. You were shooting level at the target and you were right here shooting and this was your target, your bullet would have more drop from the time it left the muzzle to the time it reached the target. Your line of sight for the target, you would have more drop than if you was shooting from here and trying to shoot on an angle up or on an angle down. There are two effects that are caused by the rotation of the earth: the Coriolis effect and the Eötvös effect. The Coriolis effect impacts the projectile on a horizontal plane when shooting north and south. The Eötvös effect impacts the projectile on a vertical plane when shooting east or west. The Coriolis effect is a result of not only the Earth's rotation, but the shape of the Earth, because the Earth is basically a giant ball spinning to the east counterclockwise when viewed from the North Pole. The surface of the center of the Earth, the equator, is moving faster than either of the poles because it must cover more distance at the same time period. So when you're shooting a long range shot, the Coriolis effect would affect you if you were shooting north or shooting south. The Earth's rotational spin could affect your shot by sending it a little east or a little west, throwing your shot essentially off target. The Eötvös effect causes deflection in two ways, both along the vertical plane of the projectile's trajectory. The first, because the Earth is a giant spinning ball, when shooting east or west, the target is rising and falling in relation to the projectile because of the curvature of the effect. So that's the Coriolis effect and the Eötvös effect. The Magnus effect. The Magnus effect is a phenomenon that occurs with spinning objects moving through fluids with flows perpendicular to their rotational axis, meaning crosswinds. So if you essentially were to drop this straight down, it's going to go without no spin to it. Essentially, if a crosswind hit it, it might move it a little bit side to side, but essentially it's going to drop straight down from where we originally released it from on its straight path. Now, if this is dropping and it has a spin to the right and it meets a crosswind, it's going, because it's already spinning to the right, it's going to take it to the right, spinning as it falls. Same thing if it was spinning to the left and it's met with a crosswind as it's falling, it's going to keep spinning and the spin is going to take it to the left. Trajectory and sights. Sights and optics are designed to create a line of sight that is at a negative angle to the bore's axis. When the sights are aligned with the target, the barrel is being pointed at a slight positive angle. Trajectory is the path that the bullet takes when it leaves the muzzle to the target. That line would be the bullet's or the projectile's trajectory. When you line up the rear sight post with the front sight post and get a line of sight to the target where you want the projectile to go, that is your line of sight. And you use the sights in order to line up that line of sight. Gravity works perpendicular to the projectile's path, which is mostly parallel to the Earth's surface, affecting its elevation, the vertical axis. Air, or more so, is the resistance it creates, known as drag, will work parallel to the projectile's travel and affect its velocity. So, in other words, when a bullet is moving forward, my hand represents air. So as it's moving forward, it is pushing through the air. That air that's pushing up against it is what we consider drag. This is known as the gyroscopic drift or spin drift. So when you have a projectile, this is dummy round, no primer. So when you have the projectile after it comes out of the barrel, it already has a right twist to it. So then when it gets hit with wind coming from, that's blowing to the right, instead of it going straight across to the right, it's actually gonna have a slight lift to it because it's already spinning to the right. And then the wind is actually pushing it more to the right subtly. So it's gonna, instead of the projectile going straight with its right twist, it has the right twist and it's gonna be slightly going up into the right, almost to like a 90-degree angle. So when you're taking your long range shots, that's when, that slight drift will make a major difference, and it needs to be compensated for.